Hello, my name is DeAndre Jones. This is my week 3 assignment for FTH Revolvers. In this week's assignment, we're going over some more of the cycles of operations and the key parts inside of the revolver. Oh, yeah, sorry, today's date is March the 6th, 2026. So for some of the key main parts, first right here we have the hand, and then back here we have the hammer strut. And then in here we have the sear that connects with the hammer. And then we have the cylinder stop right up in here. Now, some of the key things that these parts do, as an integral to the firearms operations. The hand, for one, allows timing between the trigger and the cylinder, um, which also allows it plays a part in at locking into that single double action mode. So without the hand, the hammer wouldn't cock properly. Now the hammer strut works similar. The hammer strut spring allows to put tension on the hammer so that when the trigger is released, the hammer strut will push the hammer forward so it can strike the firing pin. So without that, we'll get a failure to fire or a light strike. Same with the hand. Without the hand, we'll get a failure to cock, a possible failure to lock, and a failure to fire. Now, the cylinder stop will cause several different issues if not functioning properly. One, to prevent the firearm from the chamber from locking and unlocking, as well as properly loading the chamber. And sear plays a similar role as the other ones. One, it plays an integral role in the firearm firing, as well as the chamber cocking, um, and locking and unlocking the chamber. But more so engaging the actual um, face of the hammer. So if we have a issue with the sear, the hammer will not cock properly, which in turn will cause a malfunction. Now, to find the twist rate of a revolver or any barrel for that matter, the best method to use is going to be using, at least at home, is going to be using a cleaning rod. And on that rotating handle, we're going to set up a flag on the end. This will give us a starting point, and then we'll use a cleaning patch that will fit snugly inside of the barrel. And essentially, we're going to go ahead. Now, to get the actual calculations, does involve doing some math. So you would essentially measure the full how many rotations it makes within that length, because we're not measuring like um a longer barrel like a 12 or a 16-inch barrel. You essentially have to find how many times it rotates between the beginning until it makes how far it takes for it to rotate one full time. But because the barrel was so short, it doesn't do a full rotation. So we would have to do some measuring and essentially measure down into an inch and see how many times it does a quarter rotation, half a rotation within the inch, and you can sort of calculate from there. Um, but we do have the manufacturer's actual twist rate listed. So we don't really get that precise measurement, but that's essentially how we would try to find the measurement in a shorter snub nose revolver or anything that will be unable to get that full rotation around. Now the regular twist rate and the twist rate for the Taurus 8, but for this one we have a 1 and 16.5. And that is according to the Taurus USA website. So I'm pretty sure their website will be reliable for the twist rate.